I was assembling this K5 reverse and boiler chassis to show you the magnetized vintage armatures that Jim does for us. They're $25 if you're interested. He can convert a wired field to a DC magnet field. And I was going to do this as part of showing you the PC stuff that we've got built. And I wanted to do it with the minimal approach, for example. You don't need to buy all this stuff. You can do it this way. Well, anyway, I found this chassis. It looked great. I'd already taken the light off, which I was disappointed. I wanted to have a light on, but at any rate, I can find one and stick it on if we need it. But as you can see, there's no gear, there's no access, there's no holes, there's no way to put a smoke on here, and I'm not going to. What? No, we're not going to smoke it. We're going to show you some other methods of how you can build a fun engine without spending a lot of money early on. Okay, so I got this on and it was sluggish and it wouldn't start, and I'm like, what the heck? And I come to find out that the side rails were bent. Although they looked straight, they weren't. I took them over to my anvil and found high spots and low spots and bent pieces, so I straightened all that out. And then I found out one front wheel was off by one what do you call it? One little piece, one rotation of the threads on the output shaft. I clocked it back so it was in dead center, and then I put it back together, and then I lubricated everything and I spun it up, made sure it was great. Then I went through the armature, made sure it was clean and tight. I looked at the brushes and the springs, they're fine. Then I did the spacing. It was a little loose, so I put in a 20 thousandths shim so that it was spaced perfectly. And then I was revving it up, and before I did this, it would take 4 amps to accelerate to full speed. Now it only takes 3 amps, and it accelerates to speed much faster. So that those amps are very peak, and then they come right back down. Then I thought, okay, I'm going to shut it down. I'll turn down the volts. I have the volts turned down as low as I can go right now, and I have the maximum amp setting at about 2, but it'll float where it needs to float in order to flow. And I thought this might be interesting from some of you guys out there. I haven't tried this with many engines, but setting your engine up is so important, and making sure the wheels are square, they're not oblong, they're not lumpy, making sure your side rods are straight and they're not causing any hang or drag, making sure your wheels are clocked properly and in alignment, and then the armature is clean, the brush surface of the commutator is clean, the brushes are good condition, and you've lubricated all the spots, and you've shimmed properly. Now, one exception, I do have a roller bearing in the front, so you'll see a little extra shim to make up for that lack of lip on that roller bearing, but that's the only exception. This is, and the magnets and roller bearing, that's all I've done. And then just tune it in that you set it up to make it the best it possibly can be, okay? It's running on 2.5 volts at 7.7 amps. Now, it doesn't happen often, but I think this chassis is pretty dialed in. I'm pretty proud of it. I'm watching this one wheel. I had one wheel walk out, and I'm worried that its clamping capabilities are, oh, it's a little wobbly too. I'm worried its clamping capability. See here how it's starting to gap? I'm going to keep an eye on that. If it keeps sliding out, I'm going to have to take it off, clean it, and do something to it. But in any case, I thought this was worth sharing. You've got 2.5 volts, and then you say, okay, but does it run? It'll pull up, it'll go up to 20 at 2.7 amps. It'll go up to 20 volts. Now, I'm going to give it the real rip here. It takes 3 amps, 2.5 to 3 amps to get up to 30 volts. Now it likes to hop around a little bit. That's just the way it is. But the new version of these things sit on track. Oh, these are the new ones. I don't have a piece of track. Okay, so at any rate, you get the idea. The engine is quite robust, and the chassis allows it to be that way because it's aligned, it's square. There's no excess drag, no goofy bearings, no rubbing of the linkage, no wheel coming in and out of synchronization. It's just, I love doing this. I hate taking all the time it takes, but you just have to do it, even if you just want to show off a part that you didn't make. Jim Sheas loves that, I suppose. But in any case, this is a great setup, great engine. And it's a pull more. I was going to go non-pull more. I probably should have, and maybe I will later with a different engine. I think I have 2 of these left. I did have anyway, unless I sold them all. In any case, just let you know, alignment of your chassis before you start anything is critical. Atlantics, certainly Pacifics, but certainly the Northerns. You got to make sure your axles are square and clean, wheels are square and clean, linkages are straight and not bent and not cocked and all that. And at the same good time to get out the royal blue, or what's it called, blue magic, and polish it up, because the links on polished links always run at least 10% faster. Okay, and then make sure your armature is spaced, shimmed properly. I have 20,000 shims by the bag. They always come with the 5 and 10s, but you never get 20s. And most of the time, especially with this ball bearing, I'll need a 20 in there to get started, and then I can incrementally go up. But this is a pretty good running engine. I'm going to watch. I see that hub is starting to get longer inside there, so that wheel is probably walking out a little bit. I'm going to make sure I fix that before I get too far. But right now I'm going to go to the electronics and try to show you an assembly of the next-gen components working. That would be fun. Okay, a little bit later. Bye.